Hi all, welcome to video 4 of the Databricks playlist. So in last video, okay, basically in this video we are going to discuss about the working of Lakehouse. Okay, so in last video we have seen what is data lakehouse. Okay, we have understood all the history, right? Basically we have understood data lakehouse contains all the properties, right, from data lake and data warehouse. Okay, we have understood basically what is data warehouse. Okay, and what are the challenges of data warehouse architecture, okay, in the start. And then we learned about data lakes. Okay, then data lakes came into picture to I would say resolve the challenges of data warehouse. Okay, and then data lakes also faced few challenges. Okay, and then the data lake house architecture was developed, okay, which is having all the properties, I mean combined properties from data lake and data warehouse. Okay, and data warehouses, as we have already seen, it establishes a single source of truth. Okay, it eliminates the redundant cost. We don't need multiple systems, right? Everything is managed or maintained in one system, right? And through advantage of data lakehouse, we have seen it handles all types of data, right? Scalable, it is scalable to whatever level we want, right? It uses open source file format like CSV, avro, pake, orc, right? It removes the dependency on multiple systems. We don't need to put, you know multiple systems in place. Everything, data storage and all these things, it is doing at one place. Okay, it gives acid guarantees, okay, and the version history and architecture is very simple, right? Now we will see basically in general, right, how data lakehouse works, right? How is the working of data lakehouse? Okay, before that, we know like data lakehouse uses, okay, data lakehouse uses two key technologies, right? Two key technologies, and we are going to learn about those technologies, okay, in details in future, but I'm just giving you an overview here in the start. The first is delta lake, right? Delta lake is used to it is optimized storage layer that supports okay, acid transactions and schema enforcement and evolution. What is that? I'll let you know, right? Just have a look. Uh, Keep in mind it is optimized storage layer. Okay, and next is Unity catalog. I think many times we have so far uh, have heard about Unity catalog. It is unified governance solution. Okay, unified governance solution. Okay, unified governance solution for data and AI also, right? It is common solution for data and AI both. Okay, so these key technologies Lakehouse architecture uses. Okay, and now we will go to the working of data lakehouse, how general lakehouse work, right? Data lakehouse, how it works generally. Okay, now see, to build any enterprise level data lake house, the first basic requirement is we should have some data, right? And as I have told you, data lake house keeps everything at one place. Okay, so let's say draw one small diagram. It's not a small, a big, but okay, I'll let you know. So this is lake house. Okay, this is, let's say, entire it is lake house. Okay, now the first thing is in data lakehouse, the first thing that is done is first step is data ingestion, right? Data ingestion as in bringing the data. Okay, it is the ingestion layer where we ingest or bring the data from variety of sources in variety of formats. Okay, so data from multiple sources. Okay, sources is, let's say, dumped. Okay, dumped in multiple formats. Okay, we can get data, let's say I have I'm just putting an ingestion here. For example, this is my ingestion, right? This is my ingestion layer here. Okay, so in ingestion, let's say I am getting data from let's say three sources, right? Three sources. One from them is, let's say, Amazon S3, right? Let's say AWS S3. Okay. Then another is SQL Server. Another is SQL Server. And another, let's say, is from SAP, for example, right? So I'm getting a data from three sources. Okay. Ingestion. Data ingestion is what? Bringing the data from multiple systems, okay, to one place, to data lakehouse. So we have seen this entire house of ours is data warehouse. Sorry, okay, data lakehouse. Okay. Inside data lakehouse, we have first step of data ingestion. Okay. So in ingestion, we bring data from multiple sources in multiple formats. This data can be this data can be batch data or streaming data. Batch data or streaming data. Batch data as in, let's say we have some frequency of running, frequency of ingesting the data. Okay. For example, some pipelines we are uh, running daily, some pipelines we are running twice a day, some pipelines we are running weekly, right? So entire days data, entire weeks data, or we are running few monthly, so entire months data we are pulling from source and put it in the raw format in data ingestion layer. Okay. So this is first logical layer. Okay. Provides the place, okay, for the data, for the data to land in raw format. Okay. So we land the data here in raw format, whatever format we have at the in source, right? Whatever data we have at source, we land it here in ingestion layer. Okay. So that making it single source of truth, single source of truth for raw data. Okay. Entire raw data from source we have here. So this comes a single source of truth for raw data. Okay. Mm. Fine. Now, this data we are getting, going ahead, we can convert that to delta tables, right? Where on those delta tables, we can use schema enforcement capabilities. Okay. Schema enforcement. What is schema enforcement? Okay. The next stage is this data can be raw data, raw data, raw data can be put into delta tables, which provides schema enforcement capabilities, right? Now, what is schema enforcement basically? Okay, schema enforcement and schema evolution also. Not only schema enforcement but schema evolution also. Okay, I'll tell you what is schema enforcement. We, I think, already have seen in our PySpark series, right? There are two things. First is schema inference and schema enforcement. Schema enforcement is we define the schema from our side. Okay. For example, I have columns, let's say employee ID, employee name, employee salary. I want to keep employee ID as integer, employee name as string, and employee salary as, let's say, double or float, right? So these we define specifically and we enforce this schema on our tables. Okay. Schema means what? Column name and data type. Okay. And you all know, while reading a data frame, we have multiple read modes. We can have permissive read modes, we have drop malformed, we have a fail fast, right? Generally, most of the times we go with permissive read mode so that wherever there is schema mismatch, right, those cells, okay, or that data will be read as null, and in data ingestion layer itself we will be able to understand if there are any anomalies in the data. Okay. And we can register these raw delta tables, these raw delta tables to Unity catalog, right? To Unity catalog, okay, which is a data governance model, which is central data governance model, right? That means from this place, right, wherever data is flowing, this is raw layer, right? Wherever it has to flow, let it flow it will be managed by Unity Catalog, or it will be governed by Unity Catalog. Fine. Now, this is about and governance, as in, see, access and everything is managed at this layer. Okay, Unity Catalog manages everything. Data, it is it gives audits also. Okay, it manages the access, it governs the data. So through access we can work on data security also, right? Who should access the data? Basically, we manage who should access the data through Unity Catalog. Okay, what is Unity Catalog? As of now, just keep in mind, it is central data governance layer. Okay, it is also an open source. What is that in details? We will be seeing in upcoming videos. Okay, now this raw data we have here. Okay, the next step is now data processing. Data processing. Okay, curation, okay, and integration, right? Data processing, curation, and integration. Now, what do we mean by first is data processing? Okay, data processing means organizing, okay, organizing, okay, cleaning, right, and managing the data so that it stays useful, okay, trustworthy, okay, and easy to use, and easy to use. Okay, now this is, okay, very complex definition. In very simple terms, what we do here, we clean and validate the data. We clean and validate the data. What we do in cleaning, let's say we identify null values. Okay, identify null values. Okay, first thing, we enforce uh, I would say schema, right? Then we identify missing values, right? We identify missing values. Okay, and the next stage here is, if this raw data, okay, if this once we get the raw data, okay, once we do some cleaning, okay, we can preserve this data. Okay, preserve this data and share with anyone who is needing this. Preserve, as in, we keep this data for business needs. Okay, for business needs. Okay, and share with the, let's say, stakeholders. Okay, who wants to access the data, right? The clean data, right? After removing all the anomalies. Okay, so what we do is we are adding value to the data. Okay, whatever issues in the data, we are removing in this data processing, curation, and integration step, right? Generally, once we clean the data scientists and machine learning practitioners generally work with this data, right? And they start combining and creating new features, okay, from this data. Okay, so once we clean the data, we hand it over generally to machine learning teams, okay, or data scientists, and they work on this data for future predictions, okay, or for any business use. Okay, now basically, in delta tables, okay, in delta tables, schema on right, schema on right approach is used, okay, along with schema evolution. Okay, now I'll explain you what is schema on right and what is schema evolution. Okay, schema on right is, we are defining the structure of data. Okay, so we have raw data in the ingestion layer. Okay, we have next layer called, let's say, let me put it here. Okay, this is my next layer. Okay, which is my curation layer. For example, let me call it a curation layer. Curation layer. Okay, so what I'm doing, let me delete this. Let me just extend this one. Okay, this is my curation layer, for example. Okay, now what I'm doing in curation layer, I'm I have delta tables already created for raw data. Okay, what I'm doing in this layer is I'm using schema on write approach along with schema evaluation. Now schema on write is what it is like. We are defining the schema before writing the data to curated layer to curated layer. Okay, for example, I have employee id, employee name, employee salary, everything I'm getting as a string, right? But to use it for future purpose, I need employee id as integer, employee name as string, employee salary as double, right? I have to do some additions to salary, I have to find some averages, right? So for that, I need schema on write approach. Okay, so in schema on write, we enforce this schema, right? And if there is schema mismatch, it will throw an error, right? So it will not allow bad data to come in. Okay, and schema on write, as I told you, it is like you log the rules first. We first log the rules which my data should follow, and then only my data should come to this layer. Okay, now what is schema evolution? Evolution is like, if any new column is going to be added to the data, right? Let's say I have employee id, okay, employee name, right, and employee salary, right? That is there. Okay, already. Now let's say some new column is going to be added to my table. Let's say employee, for example, department, right? So if we, I would say, if we enable the schema evolution mode, my pipeline will not fail, right? Let's say I have 1000 records already added to this table without employee department. Okay, and now I'm getting a new column called as employee department, right? So for these 100 records which were already added, the employee department column will be set as null. Okay, and for all the other records wherever I have value, employee department will be populated. Okay, that is called schema evolution. It evolves the schema with time as and when needed. Okay, and basically for schema evaluation, if I you all know this, right? The data frame write code, right? So for example, what I have to do to set the schema evaluation mode, I'm just telling you in short. Okay, I have to just set the merge schema to true, right? And then format here would be delta, right? We'll be looking at delta in details. Okay, whatever writing mode we have to keep, let's say I'm putting it as append as of now. Okay, and dot save, here it will be file path, right? We have seen this already, I think, at the end of our pyspark playlist. Okay, that's how we set schema evaluation mode, right? So this is the layer, basically curation layer, where we see, let's say I have for example, cleaning the data. I'll just write cleaning the data. Okay, removing anomalies. Okay, removing anomalies from the data, right? Anomalies, I mean, if there is some bad data. Okay, let's say we have identified something in the data. For example, we have identified that this employee id should not be null, right? But we have identified for a few records employee id is coming as null, right? So that is anomaly in my data. Okay, that record I will send back to the source and ask them what is the issue in this record, right? Fine. So this is what cleaning we are doing in curation layer, for example. The third one, generally we call it as a serving layer. Okay. So first layer was ingestion layer, second layer was I would say curated layer, and third layer is serving layer. Okay. So in third layer, basically this data, this enriched data is served to the users, whoever users are needing that data. Okay, this data is served to those users, so users access this data through serving layer. Okay, so the cleaned and enriched data from curated layer is shared with business users, okay, based on their need, right? And that is called serving layer. Okay, so generally I just put it here also. For example, serving layer. Okay, so in serving layer we can have, let's say, serving layer 1. Okay, then I'll be having, let's say, serving layer 2, as in, I mean, a few business users are needing the data. Okay, this is my full serving layer. Okay, just a second. This is my full serving layer. Okay. Okay, let it be. Okay, so from this, okay, I'll be having multiple tables here, okay, which I have cleaned as per business requirement, right? And my, let's say, three set of users are needing this data. Okay, so what I'll do, I'll just, let me see. Okay, let me connect this. Okay, so what I'll do, where is that? Yeah, okay. Okay, this has connected. Now I want to connect this with this one. Okay, second. Yeah, okay, let it be. So from here only it will be cleaned and served, right? Okay, not this way, it will be opposite. Okay, one will go here. Okay, okay, I think you understood what I wanted to tell you, right? From here it will go to multiple layers, right? Multiple users basically. Okay, fine. So this was overall general working of data lakehouse architecture. Okay, those who already know, they are aware of these things, right? How data flows. But I just wanted to let the new people who are not aware understand that basically first it is raw layer where we ingest all the data. Then we do some data processing, we clean the data, right? We enforce the schema. Okay, we identify null values, we identify few missing values, right, in this layer. And in serving layer we serve the data, the clean data, to users based on their need, right? In the last part of today's video, it is, I'll just tell you the capabilities of Databricks Lakehouse. Okay, capabilities of Databricks Lakehouse. Okay, now the first important capability is real-time data processing. Okay, this is the place where you can do batch and stream processing together. Do batch and stream processing together in single lake house. You don't have to bring different systems for batch processing and stream processing. Okay, stream processing is like you are getting real time data, let's say transactions. Okay, let's say I have done some transaction at 1920, right? 720 of this time. Okay, so as soon as the transaction is done, as soon as it is received in the backend database, it will be ingested in our lakehouse ingestion layer. Okay, the next capability is data integration. Data integration. Okay, so basically data integration is like I have told you, it is unifying all the data to single system to enable collaboration and establish a single source of truth, right? Let's say single source of truth. So your data engineers are working in data lakehouse only. Your data engineers will work on this data, let's say ingesting the data and cleaning the data. Now this clean data will be served to business users. Okay, whoever wants to use that. So everyone, your AI engineer also will use this data, right? So everyone will work in single system with different accesses. Data engineers will have access to this data, right? And this data, I mean this layer also, business users, let's say I have, for example, let's say 10 tables here. Okay, I have 10 tables. So these business users will have access to two tables from these, right? Two tables, because they only need those tables. Okay, these business users will have access to, let's say, five tables. Okay, this group of business users, and this group of business users will have access to only one table based on their need, right? Okay, this is how it is single source of truth. Everything you have in single system. Okay, Then schema evolution. I have told you what is schema evolution already, right? If there is any addition or any change in column, okay, evolution, okay, evolution, okay, it will be able to handle, right? Then next thing, data transformations, okay, data transformations using different pyspark and sql transformations, you can do it in lakehouse in curation layer, right? The next thing, data analysis and reporting, right? So whatever data we are serving to business users, right, that is reporting, okay, and they'll do the analysis based on the need. They'll do analysis on the data, and um, they'll create, they'll make the business decisions, okay. Then machine learning, machine learning, okay, and AI, right? So whatever data we are serving as part of serving layer, or whatever data we have in curated layer, my machine learning team, okay, and AI team is going to use the same data, okay. Next thing is data versioning, right? Data versioning and lineage, okay. So we can achieve data versioning, okay, data versioning using delta lake, okay, delta tables and lineage, okay, using unity catalog. I'll just write it as UC, okay. In future, if I write something as UC, it is um, unity catalog, okay. Lineage means what? How data has flown from where to where, okay. Let's say I have 100 tables in this ingestion layer, okay. From those 100 tables, I'm creating 10 tables here, okay. I'm just joining or cleaning or doing whatever activities I'm doing, right? Now from these 10 tables, I want to understand, let's say for my table number 2, data has came from which table, right? I should have, if I find some issue in table number 2, right, I want to trace back, okay, to a source, okay, to the raw data. And if I want to understand if this is issue in my transformations or it is the issue in the source data that I'm receiving, okay. So that we able to do easily using the data lineage feature provided by unity catalog, okay. Then data governance, you all know the Lakehouse does the data governance, okay, using unity catalog, okay. Data sharing, right? I think in very first video of databricks, first or second, I told you delta sharing option is there, okay. Using delta sharing, you can securely share your data and the code you are using to other users, okay. So let's say you want to share it, you are hosting your databricks on, let's say, Azure cloud, okay. Some other team, let's say client team, is hosting their data on AWS databricks, okay. And you want them to access your delta table, okay. For example, databricks 1 is your databricks, and databricks 2 is their databricks, right? And you want to make them access, let's say, table 2, right? View access for table 2, right? In their databricks, right? How you can do? You can share this table with them, okay, using delta sharing, right? So that feature is also available in Lakehouse, and how we share using delta sharing, that also we are going to learn in details, everything, right? So these are the capabilities of data lakehouse, okay. And almost, I think, all the not all but most of the limitations of data warehouse as a single architecture and data lake as a single architecture have been resolved in lakehouse architecture, okay. Now, this was, I think, all about data lakehouse, okay. I think we'll be having, let's say, if possible, at I'll just keep one more video of theory, and then after that, it is going to be fully practical, right? We will understand each and every aspect of Databricks, okay? Each and every point why particular, let's say, window or particular thing is used, okay. So I'll try, if next video I see, I'll just make it a theoretical, the one video, and then after that it will be fully practical. But I hope now at least you have got, good idea, right? What is data lake house, okay, and how you are uh, I mean, working with data lakehouse, how you are going to work with data lakehouse when you start working on it, right? And all these theoretical things we are going to implement. So it is important that you understand the concepts, right? And once you understand the concept, implementing practically definitely is going to be challenging, but not as challenging as when you don't understand the concepts, right? Fine. I think that's all for this video. I just wanted to make you aware how data lake house works. Okay. Generally, general working of data lake house, we just put all raw data to ingestion layer. Then we do some cleanings to the data. We call it a curation layer. Okay. And then there is serving layer. We serve this data to multiple users or multiple stakeholders who wants to use the data. And this is happening under the hood, under one data lake house. Okay. Fine. That's all for this video. I hope you are enjoying this. If you have any suggestions, right, do let me know. If any topic you want me to cover in Databricks, I am going to include, I think, almost everything here. Nothing I'm going to put it, you know, as a backlog. But still, if you feel I'm missing some topic going ahead, do let me know. Any feedbacks, let me know, right? Any suggestions, also let me know. And yeah, we'll keep learning together, right? So I'm also exploring, you are also exploring, right? That's the beauty of this YouTube channel. Okay, fine. That's all from me. I'll see you in the next video. Thank you so much.